Hello all, let's start part 2 of section 2.2. Part 2 of section 2.2 is using factoring to solve some equations. Remember in my first lecture I helped you with at least 3 types of the factoring or 4 types of factoring. That's very useful in your book. Using those types of factoring, we can solve some equations that they are higher degree than 2, correct? For example, they are cubed, they are power of 4. You can solve those kind of uh, equations using factoring, but not all of them, some of them. Let me start with the example and I'll show it to you how you can use your factoring to solve a quadratic equation, correct? For example, we have 3x cubed minus 12x squared minus 15x equals 0. If you look at this problem, you see it's not a degree 2, it's a degree 3. Remember one thing, I give you a hint that every single time that you want to start factoring something, first think about GCF, the first type of factoring. If it's possible, start with GCF. If not, of course, the other types. Look at this problem, the left side of this problem. I can factor out 3 because 3 is a GCF for 3, 12, and 15, correct? And also you see x's in all terms, x squared and x, and I told you you are taking the lowest exponent as a common or factor out. Now open your parentheses and divide all terms and write the answer here. 3x cubed divided by 3x gives you x squared, minus 12 divided by 3 gives you 4, and x squared divided by x gives you x, minus 15 divided by 3 gives you 5, and x cancels out with x, correct? Equal to 0. Try to factor your equation completely. Now look at the inside of the parentheses. It's a degree 2 polynomial, or it's a quadratic polynomial. If I can factor it again, I will factor again. Keep your 3x, open to parentheses, and try to factor. If not, then make each one of them equal to 0 and use quadratic formula to solve. But here, because they mentioned use factoring to solve some equation, I'm sure you cannot factor. Here, x and x, you are looking for two numbers. To multiply gives you 5, to add gives you negative 4. Of course, the possible factors of 5 is 5 and 1, correct? You need negative 4, then negative 5 and plus 1, correct? These are the factors, plus 1 and negative 5. Okay, the important part is here to can factor. After this, use the zero property of the equations and solve. It means 3x equals 0, one equation, I will solve it. X plus 1 equals 0, another equation, I will solve it. And x minus 5 equals 0, I will solve it. From here, divide by 3 both sides, then x equals 0. Here, subtract 1 from both sides, x equals negative 1. And here, add 5 to both sides, x is equal 5. 3 answers, or 3 roots, or 3 solutions, whatever you name it. In your book, they are calling it roots. You see, my equation was a third degree. I should have 3 answers or less. In this case, you have 3 answers for this equation, correct? Let me do another example for you. One more at least. These are actually reviews. Example number 2, not 4. X to the power of 4 plus x squared minus 6 equal 0. Correct? You can use substitution method here, or in next topic I'll explain to you uh, how you can solve equations that they are quadratic in type. We call these type of equations quadratic in type or in form. Some professors they call it in type, some professors they call it in form, right? Why we call it quadratic in type? If you focus on the first term and second term, the difference between 4 and 2 is 2, right? 2 is the difference. What we do, we use substitution method to solve these type of equations. That's the easiest way. That's the easiest way. Correct? How? For example, choose another variable, name it m. M always becomes your second term. It means if m is x squared, then x to the power of 4 definitely becomes what? M squared, right? If you name x squared m, then x to the power of 4 becomes m squared. Why we do this? Because we want to change. We don't know how to deal with degree 4, but we have a chance to change it as a quadratic, solve it as a quadratic, but in your answer, substitute back the original powers and deal with, like this. Instead of x to the power of 4, I'll name it m squared. Plus, instead of x squared, I'll name it x. Minus 6 equals 0. Now you see you are dealing with quadratic. Really easy quadratic, even you can factor. M and M, two numbers to multiply gives you 6, to add gives you positive 1. Of course, 3 and 2. Negative 2 and positive 3. Equal to 0. Set each parenthesis equal to 0. M minus 2 equal to 0. It means M is equal to. And here, M plus 3 equal to 0. It means M is equal negative 3. Some students, when they reach to this step, they think, oh, I solved the equation, 2 and negative 3 are my answers. No. Focus. Is M is in your original equation? No. Then replace M back with its value. What is M? Look at here on the right side. M is x squared. Replace back. X squared equals 2. Now solve it for x. Take the square root from both sides. Square root of x squared equals plus minus square root of 2. Here, square cancels out with radical, then x equals plus minus radical 2. Or you can use your calculator. It's not necessary to give me a decimal number. Plus minus radical 2 is okay. Same thing here. I have m equals minus 3. Then I can say x squared is equal negative 3. Correct? To solve this, take the square root from both sides. Correct? We take the square root from both sides and we end up with the answer of x equals plus minus or x equals square root of negative 3. If you remember, even before going to this step, let me erase it. Let me make it easy for you, because here I'm not asking you to give me the imaginary answers, correct? I cannot do that for time being with you. But if you look at here, if you look here, under the square root, you have a negative number. And we know negative numbers, they don't have a square root, correct? We call them, if you want to take the square root of them, we call them imaginary numbers, correct? That's why we know these two are not the solutions of the equation. Only our equation has two solutions, which is x equals plus minus square root of 2, correct? Let me do another example of quadratic and form for you. X, 6x to the power of negative 2 minus x to the power of negative 1 minus 2 equals 0. You cannot call this quadratic because it's x to the power of negative 2, right? Not positive 2. But again, you see the difference between here to here is 2, correct? Then what you can do, you name, for example, x to the negative 1 m. Or in your book, they choose to use T, whatever, a different alphabet, right? Usually we use M. If M is x to the negative 1, then x to the negative 2 becomes what? M squared. Replace it or substitute, you end up with 6m squared minus m minus 2 equal to what? To 0. Factor out. Possible factors of 6 is 3 and 2. And also here m and m. Possible factors of 2 is 2 and 1. 2 and 1. We call this method trial and check method. Hopefully, those of you that you had intermediate algebra or you went to college algebra, then to this class, you know what is the trial and check method. We use the trial and check method for the trinomials, which is in the form of ax squared plus bx plus c, which your a is not 1. Actually, it's a number, correct? Now, set each parenthesis equal to 0. 3m minus 2 equals 0. Solve it. 3m is equal to 2. It means m equals 2 over 3. Also, 2m plus 1 equal to 0. Subtract 1 from both sides. Then 2m equals negative 1. Divide both sides by 2. M is equal negative 1/2. Now, replace back m with its original value. What was m? M was x to the negative 1, correct? X to the negative 1 equals 2/3. And here, x to the negative 1 equals negative 1/2. When you have a negative exponent, remember we have a formula. If I have x to the power of negative n, it's equal to 1 over x to the power of positive n. Because we cannot deal with negative exponents, right? We change the exponent to positive. It means here 1 over x equals, if you flip your left side, you have to flip also your right side, correct? Or let me explain it this way too. This way is much easier for you to understand. 1 over x equals 2/3. Now, solving this equation, correct? 2 times x equals 1 times 3. Again, divide by 2. X is equal 3/2. You see? Same thing here. 1 over x equals negative 1/2. Correct? It means if you multiply negative 1 times x equals 1 times 2. It means x is equal what? Negative 2. You end up with two answers, 3/2 and what? Negative 2. We call this type of equations quadratic in form. Let me do one more, how to deal with fraction if you have exponent in the fraction, correct? For example, 2 x to the power of 4/3 minus x to the power of 2/3 minus 6 equal to 0. Don't worry about fraction, don't get nervous. Look, denominators are the same, say 3, 3. Look at the numerator. Here you have 4, here you have 2. What is the difference again? The difference is again 2. Then name your x to the power of 2/3, for example, m or t. Then x to the power of 4/3 becomes m squared. Change it to quadratic. Then I'll end up with 2m squared minus m minus 6 equal to 0. Correct? Factor out. Possible factors of 2 is 2 and 1. Here m and m. Correct? Of course, we will not write 1m. I'll change it to m. Possible factors of 6 is 2 and 3. Correct? Here 3, here 2. One of them positive, one of them negative. Of course, the greater number should be positive. Equal to 0. Now, 2m plus 3 equals 0. It means 2m equals negative 3 and m equals negative 3/2. From here, m minus 2 equal to 0. It means m is equal to. Now replace back the value of m, which is x to the power of 2/3. X to the power of 2/3 equals negative 3/2. Now, how to solve this equation? Remember, if you raise a number on the exponent, I'm using this law. If I have a to the power of m all to the power of n, then it's equal a to the power of m times n. To remove 2/3 from here, I'll raise x to the power of 2/3, all of them to the power of 3/2. Because you see here, 2/3 times 3/2 gives you 1. That's the technique. If I raise the left side to the power of 3/2, I have to raise the right side also to the power of what? 3/2. Here, these two cancels out. X equals negative 3 to the power of 3/2. And here, if you replace m with its original value, x to the power of 2/3 equals 2. Again, raise both sides to the power of 3/2. Correct? Then x to the power of 2/3 all to the power of 3/2 equals 2 to the power of 3/2. These two cancels out. X to the power of x equals 2 to the power of 3/2. Another answer for your equation. Correct? We call this type of equations quadratic in form. I'll stop again the video here. 20 minutes is okay. And I'll do part 3 for you. In part 3, I will cover equations that radical is involved in it, and also, oh, that will be the last part of 2.2. We cover the equations that's radical involved in it, correct? It's like 20 minutes. If I do that one, it takes like 5 minutes. Let's cover it here. It's not a long lecture actually. Now we are covering solving equations because if I do a lot of videos, you will get kind of why we have too many videos for one section. Let's cover everything here. Solving equations with radicals. For example, I'll explain it in example for you how to deal with these equations. 2 plus square root of 10 minus x equals negative x. They are asking you to solve this equation. Again, it's similar to the equations, absolute value equations. Try to keep your radical. It doesn't matter if it's a square root, cube root, fourth root, correct? Try to keep it alone in one side and everything else on the other side. To do this, I will subtract minus 2 first from both sides, correct? These two cancels out. Then the square root of 10 minus x equals negative x minus 2, correct? I don't need parentheses in this step. Let's erase the parentheses. Next step, to remove the radical, you have to square both sides. You know that much algebra, correct? Square root of 10 minus x all squared equals negative x minus 2 to the power of 2. For example, if it was cube root of 10 minus x, then raise both sides to power of 3. If it was fourth root of 10 minus x, then you have to raise both sides to power of 4. Or in general, if it's the end root of something, raise it to that power. It means raise both sides to the index. We call this one index, right? The index of our radical. We call it index. You are raising both sides of equation to your index. Here it cancels out. Then 10 minus x equals, look, you have a minus b squared. Or if you cannot deal with this, multiply negative x minus 2 times negative x minus 2. Let me go this way actually for you. Negative x minus 2 times negative x minus 2. Foil it. Then 10 minus x equals negative x times negative x gives you positive x squared. Negative times positive, negative times negative gives you positive. X times 2 gives you 2x. Again, negative 2 times negative x gives you positive 2x. And negative 2 times negative 2 gives you positive 4. Then 10x equals x squared. Combine like terms. 2x and 2x gives you 4x plus 4. Now, everything move to one side and make one side 0. It means subtract 10x from both sides. If I flip the equation and write it in a nice way, it will be x squared minus 6x plus 4 equal what? 0. Oh, now I'm dealing with a quadratic equation. Very good, no problem. If you can factor, factor. If you cannot factor, then use the quadratic formula to solve it, correct? I think in this example, we can factor out. Look, we can factor it, easy. Why I should use quadratic formula? X and X equal to 0, and the factors are positive 6 and negative 1. Am I right? There is a mistake here. Let me check. Negative. Oh, that's 10 minus x. Up, 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 up. Look at my huge mistake when I combined. Sorry. When I combined like terms, I was fast. I didn't focus. I said, no, it's not the factor. Look at here. Look at here. I have 10 minus x, not 10x. I didn't see this big negative sign. Then subtract 10 and add x. Subtract 10 and add another x. Then x squared. Positive 2x, positive 2x. 4x plus x gives you 5x. Positive 4 and negative 10 gives you negative 6 equals 0. Now, correct equation. Now we can factor. X and x, of course, the factors are 2 and 3 because 5 is positive. Oh, actually 2 and 3 is not a good option. 6 and 1 is a good option, right? 6 and 1, positive 6 and negative 1. Negative 1 times 6 gives you negative 6, and negative 1 plus 6 gives you positive 5 equal to 0. From here, x minus 1 equal to 0, it means x equal 1. Here, x plus 6 equal to 0, it means x equals negative 6. When you are dealing with equations that radical is involved in it, you have to check your answer. There are two ways to check your answer. The first way is you're looking to the domain, but I'm not discussing that method here because once again, when we start chapter 3, when we start talking about functions, I will talk about the domain. Here, what we do, we will plug in back our solutions to the given equation and we check. Let me take a glass of water. I'll be back in a minute. I'm sorry that I stopped the video. I need to drink a little bit water. That's why. Okay, now, because we don't know the domain method, the easiest way is to rewrite our equation, the given equation, which is 2 plus square root of 10 minus x equals negative x, and check. Check means plug in your each solution to this equation and see if both sides becomes equal. First, plug in 1 in both sides. 2 plus square root of 10 minus 1 equals negative 1. Then 2, is this equals negative 1? We are checking. 2 plus 10 minus 1 gives you 9. Square root of 9 equals negative 1. 2 plus 3, square root of 9 is 3, equals negative 1. Correct? It means 5 equals negative 1. Is this the right answer? Of course, you see the left side and right side is not the same, so then x equal 1 cannot be the solution for this equation. Correct? Now, same way, plug in negative 6. You have 2 plus the square root of 10 minus x equals negative x. Plug in negative 6 to your equation. 2 plus the square root of 10 minus 6 equals negative x, or not, here I have to plug in my number, not x, negative 6. Negative 6. 2 plus the square root of 10 plus 6 gives you 16 equals positive 6. 2 plus the square root of 16 is 4 equals 6. 6 is equal 6. Then I checked. This one is the answer. This one is not the answer. Correct? One more example. Then I'll stop the lecture. I'll cover another type also for you. Which one? Let me take another one for you. The one that has 2 square roots on one side. Let's do one of those. They are longer, but they are not difficult. Let's focus on this example. The square root of 2x plus 3 minus 2 square root of x minus 2 equals 1. Remember, make a note. If you see 2 square roots or 2 radicals on one side, try to move one of them to the other side. Do not immediately square. You will face a lot of problem if you do that. Correct? First move one of them to the other side like this. You see, I subtract 2 radical x minus 2 from both sides. Square root of 2x plus 3 equals 1 plus 2 radical x minus 2. Now, next step, raise both sides to the index. It means raise it to the power of 2, like this. This side is easy. These 2 is canceling out. This side is a problem, right? 2x plus 3 equals. If you know a plus b formula, you can do it in one line, but I'm not pushing you to use that formula here because radical is involved. Easily you can do a mistake. Write as a 2 parentheses 1 plus 2 radical x minus 2 times another of them, which is 1 plus 2 radical x minus 2. Now FOIL. 2x plus 3 equals 1 times 1 gives you 1 plus 1 times 2 radical x minus 2 gives you 2 radical x minus 2. Now this term, I multiplied this with this. 2 radical x minus 2 times 1 gives you 2 radical x minus 2. And 2 radical x minus 2 times 2 radical x minus 2 gives you 4 radical x minus 2 to the power of 2. 2x plus 3 equals 1. 2 radical x minus 2 plus 2 radical x minus 2 gives you 4 radical x minus 2 plus 4 times. Here square root cancels out with the square. 4 times x minus 2. Now simplify a little bit the right side, then move everything after that. Move everything that radical is not involved in it to the other side of the equation and keep radical alone in one side. Correct? But before that, distribute this also and combine like terms. 2x plus 3 equals 1 plus 4 radical x minus 2 plus 4x minus 8. Combine like terms. 2x plus 3 equals 1 minus 8 gives you negative 6, right? Here and here. Plus 4x plus 4 radical x minus 2. Now the terms, which is 4x and negative 6, they don't have radical in it. Move it to the other side, correct? Let me erase these lines because you will think I will divide. It means add 6 and subtract 4x from both sides. Add 6 and subtract 4x from both sides. 2x minus 4x gives you negative 2x. 6 plus 3 gives you 9. Equals what left on the right side? 4 radical x minus 2. The only problem that you see when you are dealing with the equations that 2 radical is involved in both sides, actually it's a longer problem. You see, now I have to square again both sides and solve because I want to get rid of the radical, correct? Then raise both sides to the power of negative to the power of positive 2. Under the radical not 4, I have x minus 2. And I'll raise this side also to the power of 2. Again, two parentheses. If you don't remember a plus b formula, a plus b squared, negative 2x plus 9 and negative 2x plus 9. And square this side. 4 squared gives you 16, and this part, these two cancels out, times x minus 2. Correct? Negative 2x times negative 2x gives you 4x squared. Negative 2x times 9 gives you negative 18x minus 18x and plus 81 equals distribute 16x minus 32. Combine like terms on the left. 4x squared negative 18x gives you negative 36x plus 81 equals 16x minus 32. Now move everything to one side. It means subtract 16x and add 32 to both sides. Add 32, subtract 16x. Oh, it's a big problem. Numbers are so big. 4x squared minus 6 plus 6 is 12, 1, 4, 5, 52, negative 52, right? 52x plus 81 plus 32 gives you 103, am I right? 1012 or 13. 2 plus 1 is 3, 8 plus 3 is 11, 113, equal to 0. Numbers are so big, if you can factor, please go ahead and factor out. But if you cannot factor, this is the time that you can use your quadratic formula. Correct? Is there a mistake somewhere? Let me check. 4 squared is 16. No, that's correct. Correct? Here you can use your formula, which is x equals negative b plus minus square root of b squared minus 4ac over 2a. Use the quadratic formula, plug in your a, b, and c in this formula, and you can find the solution. But after you find the solutions, please plug in the solution back to your original equation and check if which one is the answer, which one is not. This was all about 2.2. I know I'm a little fast in my lectures because if you see it, based on the curriculum, chapter 2 is actually a full review of college algebra. And the same way, chapter 3, I'll try to be a slow down on chapter 3 because chapter 3 is really important for me. Your chapter 3, we are talking about uh, functions, and you know, those of you that you are going to calculus or higher algebra or higher mathematics courses, function is really important. Chapter 2, we will cover it right now. I'm a little bit fast, but chapter 3, you will get more detailed lecture for chapter 3. I'll stop the lecture here and see you back on section 2.4.